So hello you guys. Here's a question a student brought up earlier. Use deductive reasoning to find a certain item in a sequence. Okay, and so in this one I have kind of defined my sequence definition as this: x sub n is equal to 2n plus 1. Okay, and then the one in the homework is very similar to this. I don't want to quite give it away yet. Okay, and it's saying where n is an element of the natural numbers. So there's a couple things we want to think about here, okay? So, you can kind of think of all the skills that you use and we learn as we go along as your toolbox, okay? Because math is going to build upon itself, okay? We want to remember that, what are the natural numbers, okay? They are your counting numbers, right? 1, 2, 3, ... goes on just like that, right? Basically, it's your positive integers. Okay, notice there's no zero. That would be a whole number. Natural numbers are counting numbers. And generally in things like sequences, when you see an n and it's asking you to find a certain item in a sequence, they are talking about natural numbers unless they define it otherwise, okay? Unless they define it otherwise. So it could be something else, but generally this is what it is. Now if we want to find the fifth number in this sequence, okay, so let's check out A. What they're saying is we want to find x sub 5. In other words, okay, what this is telling us is to let n be 5. Okay, so x sub 5 means everywhere there's an n, plug in a 5. Well, in this case, what comes first, multiplication or addition? Remember, multiplication takes precedence, okay? So we would always do the multiplying first, of course, okay? And I'm sure you guys could get to 11 quicker than this. So bravo if you can. That's wonderful. So the fifth item in this sequence is 11, okay? The 12th number in the sequence, okay? They're just saying here, let n be 12, okay? So we're going to say, right, 2 times 12 plus 1. We're just using the sequence definition given above in the problem. So we would have 24, right? 24 plus 1, and that would be 25. Now just notice this, though. The way this is defined, 2n plus 1. Let's take a look at that. Side note, okay? 2n plus 1. Let's talk about even numbers and odd numbers quickly. There's a problem I'm going to do next that's going to need you to realize this. This is part of your toolbox, okay? Alright, so more toolbox. How can we represent even and odd numbers? Okay? Even numbers are always going to have a factor of 2, right? Even numbers. So we can represent, using our algebra, even numbers as always having 2 times something, right? And so let's use the natural numbers, so we'll use n. 2n. So that works. 2 times 1 is 2, 2 times 2 is 4, 6, 8. It counts up by 2's, and it's all my even numbers. So this is right. Okay? My even natural numbers, I should say. Now, what about odd numbers? Okay? Odd numbers. Okay, so what are odd numbers looking like? Odds are one off from the evens, correct? So they are related to this 2n, right? They're related. When I say they're one off, I can say either 2n minus 1 or 2n plus 1. More often than not, you'll see 2n plus 1. But it can be minus 1 as well. You just have to remember how you define it as far as when you go answer any questions that may arise. Now check it out. Here's a problem for you. Okay, let's go here. So, okay, let me get this real quick. Alright, knowing that, let me make us some more room here. Okay. And, alright. find two consecutive odd integers. Odd integers. Now, not always are you going to see, you may sometimes see these problems just consecutive integers. In this case, it's odd. And instead of numbers, I should have written integers. So let me change that really quickly. And just like that, I fixed it. So we have odd integers here, okay? Sometimes you may see consecutive integers. That would be just add one, to the next. I'll look at that in a sec. But consecutive odd integers. So consecutive, we're looking for one that comes before the other, right? So first off, what you need to first look at for this, okay, is representing first your odd integers, okay? Now earlier we said that 2n plus 1 would cut it for odd integers. Now, what I'm going to do here is I'm going to come below this problem. I'm going to start working it out, okay? And I'm going to say, okay, let the first integer be, okay? So 2n plus 1 is going to be the first integer that I'm looking at, my first odd. Okay, I'm just going to leave it at that. The next consecutive odd integer would be what? How many up from this? Okay, let's think about this. Let's kind of look at a list over here of some odd integers, okay? We have 3, 5, 7, 9. How many apart are they? These guys we have to what? Add 2 to get to the next odd integer, right? Okay, so if we have the first one here, the next consecutive odd integer would be 2n plus 1, because you have to include that whole first one, okay? So let me get my bearings here. 2n plus 1, that's my first integer, right? Plus 2. Okay? So how does this work out? Let's look at it. It's going to be my second. I want to simplify this, the expression that I defined my next consecutive odd integer. Okay, so 2n plus 3 will be my second odd. All right, so I can clean that up so that I can plug it into my equation that I'm going to write in a minute. Okay, so we have the first one and we have the second one now, right? Okay. All right, so now we need to write our equation because these two guys are going to be added together to get 48. So whose sum, what does this mean? This means I need to take the first one, 2n plus 1, right? Add it to 2n plus 3. Okay? And when I add them together, the sum is, so that is the equal sign. Typically in a word problem, the word is an equal sign. And so it's 48 multiplication. So really I can go ahead and rewrite this with my like terms next to one another because addition commutes. It's commutative, right? Meaning I can choose which two I would like to add up first. Okay, so we'll put the plus 1 here, and then we'll put the plus 3 there. Okay, and go ahead and bring down the rest of your equation. A lot of people don't bring down. They'll try to just work on one side and then bring down everything later. Bring everything down you have not worked on yet. Notice I'm skipping lines too. Okay, so we're going to combine now these two guys. If I have 2n's plus 2n's, that makes 4n's. Think of apples. 2 apples plus 2 more apples makes 4 apples. It's funny, but yeah, all that kindergarten addition will help you sometimes with algebra. So, and then we have 1 plus 3, and that makes 4 as well. Okay, so now we have a little simplified equation we can solve for n. So let's find n. Let's find n, excuse me. So now we want to get n by itself when we want to solve something. Okay, and by the way, we should solve this equation. Now, alright, so now we want to get rid of first this plus 4. So we're ultimately trying to get the n by itself, right? Okay, let me just highlight that real quick just to kind of remind us this is the item we're trying to isolate on it by we're trying to get it by itself on one side of the equal sign, right? Okay, so here we go. If I have 4 added here, I can do the inverse operation of subtracting a 4. What I do to one side, remember I talked about the scales being balanced, that the equal sign is like a scale, we must remain balanced. If I take 4 ounces off of my gold scale, I need to take off of one side, I need to take 4 ounces off the other side, right? We don't want it to get unbalanced. So now I have on this side 4 minus 4, these guys will cancel out, okay? And on the right side, 48 minus 4 is 44, okay? So let's write down now what is left. I have 44 on the right side, and I have this 4n left on the left. And now, what is the deal? What do I need to do now to isolate n? Okay, think about what's happening with that 4 that's attached to it. What is the operation between them? There's nothing there really listed between them, but what's implied? Can you tell me what is the implied operation between 4 and n? Okay, so you don't always have to have a symbol between two things multiplied, especially if it's a number and a variable. So this is multiplied, okay? Here, I'll put a dot just to kind of help you out. What undoes multiplication? What reciprocates or is the multiplicative inverse for multiplication? Division. So over here on the left, to get n alone, I need to divide off whatever's multiplied by it. Of course, like I said before, the property of equality, we want to do the same thing to the right side that we did to the left side. Make sure you match, okay? So now, for a number over itself, right, or 4 divided by 4 is just 1. So you see these guys cancel. And on the left, you end up with n. Now, 44 divided by 4 is 11. Okay, now we need to kind of come back and answer our question. We need to find the 2 consecutive odd integers. Our first one was this one, and our second one was this. Okay? And if n is 11, okay, so n is 11 kind of helps us get to the answer, okay? All right, so what you're going to do is you're going to plug in 11 for n. Okay, easy enough, I think. So here we are. We're going to go. The first integer would be 2 times 11 plus 1. The second consecutive odd integer will be 2 times 11 plus 3. What do we have here? 2 times 11 is 22 plus 1. So 22 plus 1 is 23. Make sure they're odd, right? This is the first consecutive odd integer. And then 22 plus 3 would be what? 25. Definitely want to think about whether this makes sense. First of all, are they odd integers? Yes, they're odd. Are they consecutive odd? Well, sure. 25 comes right after 23. And lastly, you want to check to make sure their sum is 48, right? So let's do that. 23 plus 25. Sure, 5 and 3 is 8. No carryover, and here's 48. Okay, so yeah, there you go. That's the two. These are the 2 consecutive odd integers whose sum is 48. I'll talk to you guys soon. Let me know if you have any questions, okay? Thanks. Have a great day.